Hi and Assalamualaikum. My name is Amalina Ashila binti Alias and my supervisor is Dr. Rezwan bin Abdul Manap. The title for my PSM project is Blind Image Quality Assessment via Patch-Based Learning Framework. What is IQA? IQA is a measurement that we can estimate the quality for each image. IQA aims to quantitatively represent the human perception of quality, where it can give a score for a certain image during transmission in the computer. Demo score is a score that is made by human. So, at the end of the result, we will compare using result from the project that has been proposed. First thing first, let me introduce about the project background. First, we need to insert the image in the model, and the model has two stages. Stage 1 is extracting features from the image in statistical form. After we get the result from feature extraction, we insert the result on stage 2, which is the regression model. Function regression is to train the image how to make a prediction quality score. Regression has various algorithms, for example, SVR, SVM, or neural network. The previous BICA model required intensive regression parameter trainings. In my project, I am using the nearest neighbor algorithm because the training cost is very minimum. It will automatically compare using a database and produce the result. To train their regression model, most BICA models use an 80% of training set and 20% test set. To build the dataset, this project used the same partitioning method. The features for the dataset are extracted using the patch from 80% of the randomly selected reference image from a standard IQA database and their distorted version. There are two problem statements in my project. First, most models are made into stages with various types of features extracted first and then used as input to a regression algorithm. Intensive training is often required. Second, other models usually extract features at the image level. They can only provide an estimated whole image quality score. The major contribution of this project is that it used nearest neighbor learning method to predict quality without the requirement for a prior training phase, which is required in many previous models. Other important features include the ability to recognize image distortion and give a local quality estimation, even though both are not present in most BICA models. Okay, next, this project has three objectives. First is to extract relevant quality predictive spatial domain image features at the patch level. The spatial domain is to transform the original pixel value to one domain where it is a statistical value. It is a feature that does not directly represent the pixel value. The second objective is to develop a quality prediction model through nearest neighbor method utilizing the extracted features. Third objective is to analyze the model performance through comparison with several available BICA models in terms of prediction accuracy, generalization capability as well as computational requirement. Prediction accuracy is mean square error and correlation. Generalization capability means we are using live database for training image. For the proposed model, I am using image patches because the previous project only used the full image to get the quality score. My proposed model used patches to get the score because we don't know where the distortion occurs. When using the patch, we can detect the distortion on each of the patches. For the next stage, we make feature extraction using the GMlog, which has 40 features, then using nearest neighbor regression algorithm to process it, and it will produce a quality score for each patch. And lastly, we sum the total patch score and produce only one quality score image. Okay, next, I will explain about the patch extraction. The first image is the original image. Then, I will use the sieve method to find the interest point. In one image, basically, there are 1,000 interest points, but in my project, I will take only 30 interest points for computational purpose to minimize memory requirement. To make it clear, this is the original image. Then I am using sieve detector to make patch sampling. This is the example of the patch that I will make feature extraction. There are 40 features that will give us information about the quality of every patch. To investigate the effect of patch size variation on the prediction performance, It was tested on the live database with 5 different patch size, which is 10, 30, 50, 70, and 100. So, this is my result for comparison with different patch size. As we can see, better performance when our patch size getting smaller. A smaller patch size will lead to a larger number of samples for the label dataset. Having a large number of label samples will help a model to obtain better learning capability. The dataset size is determined by the number of label image and the number of patch within those images. A larger dataset will require a longer time to compute the I2C distance between the test patch and their nearest neighbor label patch. This is comparison result with several available BK models. What is SROCC and LCC? SROCC is the Spearman rank order correlation coefficient, which is used to predict the monotonicity of performance parameter, and the LCC is linear correlation coefficient is used to predict the accuracy of each image. There are 5 distortion classes in live database, which is JPEG, JPEG 2000, white noise, G-blur, and fast fading. The experiment will perform 1000 times to ensure that the results are not governed by the specific train test partition. The result is for individual distortion and overall distortion. As you can see, GM-log and breeze is the best performance parameter. This is the result for RMSE. From the result, we know that GM-log is the best performance parameter. This is the average runtime for different available BK model. BK is the fastest, but it has the worst prediction performance. GM-log is a better option when real-time computation is not a key requirement. For the sustainability, social and environment impact, the project is computer simulation based and does not involve hardware elements such that there should be minimal effect on sustainability and environmental aspect. There are no usage of chemical or any material that can be harmful to the environment. Lastly, for marketability and commercialization relevancy, this model is useful for image improvement and restoration as well as transmission, where there is a need to ensure a satisfactory level of image quality without the presence of a reference image. In many real-world visual applications, the availability of the reference image does not exist, and only the distorted image is available. As a result, this model has the potential to be used in real-world application. This project is software-based. Now, I will show the project functionality using MATLAB software. This is the coding that I use. This is the database coding that has been created to store image, distortion class, number of reference image, and DMOS score. This is the coding for feature extraction stage, which is GM-log. Then this is the coding to set the patch size. We can set the patch size for one image. Here we can see that I am using 30 patch for one image. We can set whether we want to use 10, 30, 50 or 100 patch. Okay, this is the coding for removing reference image in the database because we only want the image with distortion to perform this. In the live database, we have 982 images including the reference image. So, this is the total image after we remove the reference image. In this project, I am making 1000 experiments to guarantee that the obtained results are not influenced by the one particular train test partition. But I will only demonstrate using only one experiment in order to save the time. Basically, this is the coding that I am using to produce the result. Now, I will demonstrate the project. Okay, we can see that this is the result. This is the dataset. It has 30 patch and 40 features. So, this is the result to show the overall median for LCC. This is the overall result for median RMSE, and this is overall median SROCC. So, in conclusion, we can use the result to compare with the prediction that is made by human. Okay, that's all from me. Thank you for watching my video.